Welcome everyone to our second day of the ST3D science meeting, and this session is going to be all about GALAH, and we're going to start with Josh giving us the overview about the GALAH survey.
Thank you, Stefania. I hope everybody is well. It's always rather unnerving giving these short review talks, overview talks, because I'm bound to leave out somebody's work. It's rather a compressed time frame. I apologize in advance. I've tried very hard to grab some of the most topical developments. And of course, there are lots of other things going on. So let me start by saying there's a very new and brilliant website prepared by Jeff Simpson. You can see up here, galah-survey.org, a very simple link. And this, I think, is probably the best website we've ever had describing the GALAH survey, its goals, science results, updates on the survey, papers, and so forth. It really is rather beautiful. And it gives you links to how you can get going with GALAH DR3 in particular. And this is just I've just given you a quick sort of overview of some of the students working on projects. Hilary is doing a master's on these data. Nabo is doing a PhD, and Maria is doing an honors, finishing up a rather brilliant honors on following up the GALAH Gaia recent publications. Really very exciting. It does attract a lot of students these days. So as you know by now, there's a lot going on in galactic archaeology. ESA, Gaia, NASA Kepler, NASA TESS are three incredible missions that are providing beautiful data, both in terms of distances and proper motions, parallaxes, and stellar ages and masses. On top of that, ESA Gaia produced a catalogue of about 6 million stars with very accurate phase space, XYZ, VX, VY, VZ motions, and that's particularly exciting. The picture you see here is an optical image obtained from Gaia. It's like a pointillist picture. It's been reconstructed from billions of measurements of stars, probably in this case 100 million measurements of stars across the sky. So you're seeing the galaxy reconstructed from points of light, basically. It's quite beautiful. So if you go to Jeffrey's beautiful website, he has some summary slides that you can look at. They're updated on a regular basis. And this shows you the kind of survey footprint that we have at any given time. There are different kinds of surveys going on, all in parallel. There's the GALAH survey in the pink circles, the K2, that's the Kepler follow-up survey that was started by Sanjeev and Dennis Stello at University of New South Wales. Now we have the TESS Hermes survey. On the back of the Kepler success, the TESS success has been very good as well, because these surveys give you good ages. And there's open cluster surveys. This one's led by Gaia de Silva. So it doesn't need to be a contiguous field. We just have to make sure that we've covered the sort of cardinal directions and zones for the main science goals. And we're achieving, and I should mention that in phase 2 of the survey, we are not just targeting old stars, we're targeting stars on the main sequence turnoff, i.e. stars with good ages. Because when we combine that with, oh gosh, my phone's going, apologies. When you combine that with the stellar ages and masses from the Kepler survey, so forth, and TESS, we get very good ages for a large fraction of our stars. So, and also there are summary slides that show you how the survey is tracking. This is from 2014 onwards. The different colors show you the different amounts of stars being observed under each of these surveys. So GALAH dominates, but we're getting very good science results from the K2 Hermes and the TESS Hermes surveys. And you can see what's happening on Sky. There's been a sort of an acceleration of activity in the last few semesters, and we've got good time allocated in the next few semesters ahead of us. So we're up to about 750,000 unique stars at the present time, and we're well on track to achieve 1 million plus stars by 2024, 2025. So we just need the AAT to survive long enough for this to be achieved. So it's really quite extraordinary how well we have done through all the trials and tribulations of COVID and so forth. All right. Okay, so one of the benefits of GALAH is not just getting this high dimensional space for chemistry, which you'll have heard about, 30 elements. We also get very good radial velocities. So this is apparent magnitude of the star against the mean radial velocity. And you can see that Gaia, typically for cool to warm stars, is not particularly good in relation to what we're achieving, sort of between 1 and 2.5 kilometers per second. We're down at about 0.3 kilometers per second. I think this is a real advantage, because it means that we can, not just with the chemistry, but also with the radial velocity, we can add value to a subset of the stars. And the stars that we've chosen in Gaia are stars that have 1% distance errors, basically. So we really have very good precision on 3-dimensional, 6 dimensions of phase space, position and velocity, in addition to having these elements of chemistry. So we have a very large parameter space to go after. And the data releases themselves, as you'll see in a moment, are having an impact. DR2 is having big citations. And so to the point now where it's not always cited. It's cited a lot, but it should be cited even more. People just refer to GALAH DR2 in some papers. And GALAH DR3 already this year is having
Can I just show you a couple of quick
impact. Does somebody mute their screen? Okay, so scientific impact, the GALAH team itself, with GALAH survey papers, we're averaging around 10 papers a year. These are very sizable pieces of work. We also have additional papers where we're working with affiliated surveys like the K2 and the TESS. That would increase us by about 50%. And then there are modeling papers, which would increase it by a factor of 2. So I haven't had a chance to mention all the affiliated work that comes under the banner of Astro 3D. So for example, Sanjeev Sharma and Michael Hayden have some beautiful papers on chemical evolution modeling this year. They've had 3 papers each. And they've had tremendous impact in terms of people using their models, and those models will fold back into the GALAH survey papers in the years ahead. But look at the impact that GALAH is having external to us. So you can see the rapid rise in the usage of papers being written based on GALAH data, and we're on track, as you can see, just to basically, and you can see that they are, we're down at here, sort of 0 to 12, let's say. They're up at sort of 50, 60 papers, going on 60 papers a year. This is the way it should be. The releases should be important enough that others will want to use them. So now we're able to do some very big science and also tap into science that was identified by other groups. You may have heard about this building block called Gaia Sausage Enceladus, GSE, sort of discovered by 2 separate groups, hence the 2 key words being merged together as one. And this is the Milky Way. And on this scale, GSE appears to be something like a bar-like distribution of stars that was accreted at redshift of 1 to 3, let's say. And the GALAH DR3 survey, which gives you sort of elements like alpha to iron, to iron to hydrogen, lithium, carbon to iron, and so on. There's like many elements, of course. We're able to use this survey with our kinematics, with the Gaia kinematics, to establish whether we can determine chemical tagging of this particular system as well. And we do that quite successfully. So this is coming up in Sven's short talk later today, where we identify, for example, magnesium to manganese, sodium to iron, and the stars in GSC are offset with respect to the background. And what's really beautiful is that carries over to dynamics. If you look at the radial action, how much the stars are going in and out in the galaxy. Same also in up vertically, up down. You can do this in a 3-dimensional space, of course. And LZ is angular momentum around the galactic disk. When you combine that chemistry with these actions, LZ is J phi. It's basically, these are 2 of the dynamical actions you can determine from the 6-dimensional phase space. So when you combine this together, these stars are offset with respect to the background, which is grayscale in both of those figures. So chemical tagging is working, especially when you bring in the dynamical information as well. Another key result, which is very exciting, is the GALAH survey of the local galaxy, star clusters and star formation of the local galaxy. This is the Orion complex. You'll recognize that from this sort of stick figure here. And there are about 30 or so star clusters identified within the Orion complex. This enabled Janis and the GALAH team to determine a mass function. But that also identified a mystery. The age span is now known from our work to be 8 to 21 million years, not 8 to 12 as was thought before. It's a much longer time span. The total mass of this system, when you sum over all the star clusters, is like 5,000 solar masses. And in that time frame, you'd expect 50 supernovae to have gone off. What's extraordinary, as Janis shows beautifully in his paper, is that the star clusters across the entire complex are highly chemically homogeneous, showing enrichment from prior supernovae before the star formation complex went off. So why on earth we don't see the enrichment signatures of these 50 supernovae has been a source of conversation with people like Chris McKee, Mark Krumholtz, and others. And it may be that once one supernova has gone off, basically, and the thing begins to break up, that the rest of the elements go into the hot phase. It's not clear at all what's going on, but I mean, it's the sort of thing that we're trying to understand. But I think you'll agree that this is really profound. You know, this goes to mixing of elements and how stars are formed in the local galaxy. So this is another of the rather exciting papers to have emerged from this survey. this work is continuing. The GALAH team are now looking to extend this into the local galaxy. This is 500 parsecs on a sorry, plus or minus 500 parsecs into the Milky Way. We're in here somewhere, and this is Pleiades, this is Orion. All the blue dots that you see in this image up here are stars that have already been observed by GALAH, and there's work going on, hopefully, to fill out the stars from the GALAH survey in these complexes as well. This is how it looks on the sky. So you can see that these are sort of adhere to the Milky Way plane as you'd expect. So this is really quite interesting because there's much to learn. We don't know really so much about how stars diffuse from formation sites, how gas and metals mix. And maybe one of the questions that we'd like to understand is are all these elements which are being created as soon as a cluster has collapsed in this way, have they all gone into the hot phase? So you basically have to find the cooling phases out of the hot phase for the next generation of star formation. If this is the case, this is the kind of thing that has to go into the microphysics of n-body cosmological simulations. So this kind of work, as I write here, underpins all of the star formation in galaxies, I would say. All right, so in the time that I have left, which I think is just another minute or so, I think I've only got another minute, haven't I?
Yep.
So, so the mission is to be extended, and what we'd like to do is to follow up this work with, so EDR3 has already been done down, but what we'd really like to do is, what we're keenly awaiting is Gaia DR3 in mid-2022. DR2, Gaia DR2 has already fed into all the surveys I've mentioned and had a huge impact on GALAH. It's produced something like 3,000 papers at the last count. I forget now how many, but you can imagine that Gaia DR3 will have an even bigger impact. It will produce a catalog, phase-based catalog of 35 million stars. We had 6 million under DR2. We'll have 35 million under DR3. And so we would hopefully be able to extend the kinematic information further into the disk. You know, at the moment, we're sort of like around 100 parsecs or so around the sun, that 6 million catalog, and the 35 million catalog hopefully will enable us to track further into the local disk. So how much time do I have? Sorry, Stefania.
1 minute.
1 minute, okay, thank you. So I wanted to make one more point, which I forgot to raise earlier. I apologize. Yeah, so I seem to have turned off one of my slides. I apologize, not to worry. Okay, so I was going to mention that the other papers which are happening at the moment are to do with lithium. You're going to hear from Sarah and Jeff, beautiful new work on lithium, which has impact in terms of the cosmological lithium from local star measurements. And there's also a mystery emerging from lithium in terms of why it seems to be detectable in the red clump giants and so forth. So there's a lot of science going on. It's just that we haven't, I haven't had a chance to go through more of it. Thank you very much.
Thank you, Josh. Any questions for Josh? So you can answer questions, just a reminder, raising your hand on Zoom or on the Zoom chat or on Slack. So we have a question from Katie. How do you manage to tag millions of GALAHs? That seems quite time consuming and not RCPCA friendly, Josh.
Sorry, just let me just have a quick look at the chat window. I didn't quite catch all of that question. Yeah, how do we manage to tag millions of GALAHs, right? Yes, a very profound question. We as a team are trying to tag stars in a uniform way in a multidimensional space, and that is proving to be quite a challenge, actually. So I think the tagging that we're doing, which is most effective, is tagging which is underscored by the dynamics. So if we were to tag blindly in terms of the background population, we can identify a few systems, but not quite as many as we'd hoped. And that's because astrophysics hasn't been as friendly as we'd hoped. You know, the chemical uniformity in large regions appears to rule. So it's really the outliers which are proving to be interesting. Things like accreted building blocks, as you'll see from Sven's talk.
Okay. Thank you very much, Josh. So we have another, not question, but comment from Richard, a great comment. So is congratulating for the recently awarded 2020 Water Bus Marathon by the AIP. So congratulations, Josh. And